Hello everybody, I am Kateryna and I'm super excited to be joining you virtually today to talk about accessibility. Accessibility is a part of inclusive design and it is all about ensuring equal access for people with disabilities. And you're likely familiar with different accessibility features in public space, such as curb cuts, ramps, elevators, and sliding doors. They help to remove barriers for people with disabilities. But similarly to how curbs can be challenging for somebody using a wheelchair, some of the features of our digital products can create quite literal barriers for somebody using assistive technology, such as a screen reader, braille keyboard, switch device, or voice control. And one of the most common examples of such features in our digital products are different types of forms. Be it creating an account or logging in, buying and paying for things, searching, sending messages, and more, often the only thing standing between the user and their goal is a form. And this is exactly what I want to talk about today. This talk will be a practical guide on how we can implement accessible forms on the web. All of the examples during the talk will be in React, but all the principles will still apply if you use a different framework or if you're just using HTML as well. But first, konnichiwa, hi. My name is Kateryna. Let me introduce myself really quickly. I am from Ukraine, but I've been living in Estonia for the last few years. I work remotely at Buffer, where I'm as an engineering manager leading our front-end direction. And I'm also organizer of Tallinn.js. So if you're ever in Estonia, which is, I know, a long way from Japan, come to one of our events and meet Estonian JavaScript community. But we have quite a lot of ground to cover, so let's start. And I want to start by going through some of the foundations of web accessibility. So we know that on the web, everything starts with HTML, which describes the page structure and its contents. But if we look at it, HTML on its own is just a long piece of text. It doesn't do anything. So in order to display something in the browser needs to parse it. So it does it by transforming it into a DOM tree, or document object model. Then out of the DOM tree, it can generate the visual UI that user can see and interact with. But it actually doesn't end there. When it comes to accessibility, out of the DOM tree, browser also generates what is known as accessibility tree. It is a subset of DOM tree, which contains all the important information for assistive technology, like a screen reader. Then this accessibility tree gets exposed to assistive technology via a special API and can be used to navigate the page. But it's a lot easier to understand with an example. For example, for this HTML page, accessibility tree will look something like this. Note that not all of the elements are present within the accessibility tree. For example, the div that we use for styling of our title is completely omitted. Each element within the accessibility tree has its role, which describes what kind of element it is, what is its purpose, and an accessible name, which identifies it. In this case, for our button, it is inferred from the contents within the button element. Additionally, it can contain a lot of other properties that can describe it further or communicate its state. You can actually see all of this within the DevTools. In the Chrome DevTools, there is accessibility tab where you can see all of the accessibility tree properties we just discussed. Or you can even toggle the full page accessibility tree and see the accessibility tree for the whole page. It is very useful for debugging when you are working on different features, but also it can be fun to explore and install as well. Now, this tree gets exposed to assistive technology, like a screen reader, and will be used to navigate the page. Let's see what it might look like.
Page with content. Heading level 1. Hello. Waving hand. Image. Main. Let's learn about accessibility. Start button.
As you can see, or rather hear, the screen reader announces information straight from the accessibility tree. It uses the accessible role to identify type of the element and the accessible name to identify what the information, additional information about this element. So in this example, we navigated the page sequentially. But screen reader users actually have a lot of different shortcuts to navigate the page by different landmarks, headings, interactive elements, and so on. And this is exactly why using semantics and semantic HTML elements is so important. Semantics convey meaning, because while theoretically we could make anything in HTML look like a button with some additional CSS, it won't give information for somebody who cannot see all of those visual cues what kind of element it is. So by using semantic HTML elements like a semantic element button here, we can convey meaning behind the code. Additionally to getting a lot of built-in behaviors for free as well. And there's more than 100 different HTML elements that come with built-in semantics, different roles, states, and other attributes. And by using them, we can make our code more accessible on its own. Now, as we understood more how assistive technology works and interacts with the web pages, let's talk about forms. Throughout this talk, we'll be using the sign-up form as an example, and I will guide you through implementing various accessibility features in it. But before diving into some meatier subjects, let's address low-hanging fruit first, which is focus indication. You know that by default, browsers provide focus outlines for all interactive elements on the page. And it indicates which element is operable right now via keyboard. However, often when these outlines don't match the aesthetics of the design, they are either completely removed or replaced with something that is barely distinguishable. Unfortunately, this makes experience for keyboard users really confusing. Imagine using a mouse without being able to see cursor on the screen. So instead of removing them, we can create custom, beautiful, and legible focus indicators that match our design language. I think in my case to give it something little extra. But what's more, we can also use focus visible pseudo class in CSS, which is already well supported in modern browsers, to make sure that the focus indication is only displayed when element is navigated via keyboard and not the mouse. Which kind of lets us achieve best of both worlds. We maintain design aesthetics for mouse users while keeping it very functional and legible for anybody using the keyboard. Now, as we address the focus indication, let's talk about labeling. Because imagine filling a form like this. It seems confusing, right? Unfortunately, this is the experience for a lot of people using assistive technology. So it is important to provide clear, accessible labels to all inputs within the form. In our sign-up form from before, we've been using placeholders to describe inputs. While it is a very common practice, it has several accessibility concerns. First of all, they're often a lighter shade of gray. Therefore, they can be less legible, so harder to see with people maybe in the bright light or people with visual impairments. But also, they disappear as soon as you start typing. So it might be harder for people with cognitive disabilities such as ADHD to keep track of inputs, especially in long forms. But what's more, they also have a very low support in assistive technology. So in different versions of the screen readers, they are likely to be completely ignored and therefore won't be announced to the users. So instead, it's better to have a clear, visible label near the input, and let's see how we can implement it. Specifically for this purpose, we have a label element in HTML that we can use. And when positioned near the input, it visually will already convey the information and describe the input. But if we listen to the screen reader,
edit text, blank.
We see that it doesn't pick it up. To understand why, let's look into the accessibility tree. In our case, our input doesn't have an accessible name. This is because screen reader doesn't recognize that this label belongs to this input. To fix this, we need to explicitly connect them with for and ID attributes. In the case of React, we call it HTML4. Now, contents of the label will be used as an accessible name for our input and will be announced like this.
Username, edit text.
Perfect. This was explicit binding, right? We use for and ID attributes to connect label and input elements. We can also bind them implicitly by wrapping label around the input element. But generally, this method has less support in assistive technology. Therefore, even if you use this, it's better to still bind them explicitly as well. Now with labels, our form is already a lot easier to fill. And while we generally want to display visual labels where possible, there are still quite a lot of cases in the user interfaces where we might want to not display a label, or the purpose of the element is evident from the context. Let's do a little bit of a detour and talk how we can implement hidden labels within the UI. Search input is a really good example of that. It is a really common pattern, and therefore it is very recognized for users within the UI, so we might not want to display an additional label near it. So let's see how we can implement this without compromising accessibility. One way to do that is to still kind of add an HTML label near the input, but we can hide it from the visual UI with the visually hidden technique, which is basically a CSS class that we can add that shrinks this element and hides it out of the viewport without taking up space in the UI. This is a very common technique that is used in different cases where you might want to still have information for in the accessibility tree, but not displayed in the visual UI. Then contents of the label will still be used to announce element on the page. If you have a design system or component library, you can create a visually hidden component specifically for this case to make it easier to use without copying the CSS all over again. It is also handy to provide a polymorphic way to set the as attribute to set the type of the element that you want to render this element as, like you can see right now on the screen. And it's especially useful, for example, for icon buttons. So you can provide an accessible label within the icon button without displaying anything beside the icon inside. But now if you look here, we actually kind of have this search label twice. We have it in a hidden label and in a submit button in our search field. So what if we could use something else that is not a label to describe our input? In order to understand how to do that, we need to learn more about ARIA. ARIA stands for Accessible Rich Internet Applications. It is basically a set of different roles and attributes that we can complement native HTML with. They're all defined in this spec, which adds additional roles, states, and other properties that we can add to native HTML to improve how they are perceived by assistive technology. For example, divs by default are generic containers, so they don't provide any meaningful semantics. But we can set a role of a button to the div to change how it is displayed within the accessibility tree. Important note is that with all of the ARIA attributes and the role attributes included, that it won't actually affect appearance or behavior in any way. So we can treat ARIA as this kind of promise. We are promising the user that this div is supposed to behave like a button and is intended to be a button, and it's important to fulfill that promise and provide all of the expected behaviors by implementing them usually with custom JavaScript, CSS, or HTML. But as you can see, it actually takes quite a lot to implement a button from scratch. So in most of the cases, we should still opt for native HTML elements because they generally have better support and also provide a lot of useful behaviors and semantics out of the box. But where ARIA roles are the most useful at is implementing interactive patterns that don't exist in native HTML, such as tooltips, tabs, combo boxes, toolbars, and so on. Additionally to roles with the role attributes, there are also a lot of other ARIA attributes that are defined in the specification. They're all set with ARIA-something that we can set on the elements. So in our case, we can use the ARIA labeled by to connect the button, which contains the search text, to our input. So in here, we define ID for the button itself, and then we connect it to the input with ARIA labeled by attribute. Then contents of the button, basically accessible name of a button, will be used as an accessible name for the input. And it will be announced like this.
Search text field, blank.
Additionally to area labeled by, there's also area label attribute as well. And I intentionally put it last because I find that it's probably out of the three options that we discussed, it's probably the worst. So the way it works is that we can set area label to the element and it will override the accessible name, as you can see right now here in the accessibility tree. And I think area label is very useful, and it's usually the first area attribute that we all get exposed to when learning about accessibility, it also has some downsides. For example, it won't get translated if the browser has translation features on, and will keep its original language. But also, something that I find is that with the best intentions of making accessible experiences and so on, we as developers tend to overuse area label. For example, here it is just not necessary because contents of the button can be used as an accessible name. But in some cases, like here, it can even be harmful because right now the accessible name and the visible name are different. And for users who, for example, utilize voice control and they need to speak out kind of names of the elements in order to activate them, they will speak settings, but it won't be picked up because the accessible name within the accessibility tree is open preferences. So in most of the cases, if we can use the rule as no area is better than bad area, and is actually included as the first rule of area in the area authoring practices. Now we learned about labeling. To provide visible labels for the label element, but also 3 different ways we can set hidden labels for our controls. We generally want to keep labels clear and concise, but sometimes we want to convey more information with different hints and instructions to guide users through the form completion. So let's see how we can implement that. We usually display a hint or instruction underneath the inputs. To implement it, we can just place the text underneath. But there is also this little special way that the screen readers treat forms. Often when they enter a form, they activate different navigation strategy. They prioritize only interactive elements, therefore everything else that is positioned within the form element in HTML can be completely omitted, and therefore users won't be able to hear this text. So instead, we need somehow to connect it to the input itself. To do that, we can use accessible description. By default, most of the elements it is empty, but we can set it with another area attribute called area described by. And we can connect it with ID attribute similarly to how we did with area labeled by as well. Then the accessible name of this element will be used as a description for our input. And usually it is announced after a pause, like this.
Username, edit text, must be between 3 and 20 characters long.
As you see, we are kind of using a lot of IDs in order to connect elements within the page for better accessibility. To make it easier, React, for example, has a useID hook that you can create IDs automatically without needing to set them manually all the time and to make sure they are unique. You can just generate this ID and set it in all of the different cases where you need to connect all of the things together. So now we learned how to add hints and instructions to our forms. Another pattern in forms are required and optional fields. So often, especially in logo forms like ours, we have a combination of required and optional fields, and by clearly indicating which is which, we can guide users better through the process and decrease the chance of mistakes. So in our form, we have 3 required and 2 optional fields. Typically, the most common way to mark required fields is this red asterisk symbol that we can display near the label. Let's see how we can implement this accessibly. If we just add an asterisk inside the label, the screen reader will actually pronounce it like this.
Username star, edit text.
Which can be confusing, And as you will start using the screen reader testing things, you will notice that it's actually the case with a lot of elements we might use for presentations, different icons and separators and so on. So to avoid that, we can use another area attribute called area hidden. If it is set to true, the element will be hidden from the accessibility tree, therefore won't be announced. And it's very useful for various elements you can use for decoration within the UI. So cool, now we have this visual cue with an asterisk, but we still need a way to provide semantic cue for assistive technology users. To do that, we can use the native HTML required attribute. But together with the semantic, it will also introduce default HTML validation, which is a little bit inconsistent, but also is not very flexible. So in most of the cases, for better user experience, we might want to implement our own validation instead. So now we want the semantic cue, but we don't want the associated behavior, which is exactly the use case for area attribute. So we can set area required attribute instead, and now it will be announced to the user like this.
Text.
So while marking required fields is a very common approach, a different way we can explore is marking optional fields instead. This way the form can be visually perceived as less threatening, but if you use this approach, I would still recommend leaving the semantic area required attribute on for the inputs to make sure that for screener user who cannot perceive the form as a whole, they know which input is required. Now, despite our best efforts of making our form intuitive and easy to fill, we can never eliminate human error. And how we validate user input and display error messages can have tremendous impact on the user experience of the form. So let's dive into how we can implement our own validation within the forms. But before that, let's consider a few important aspects. First, to indicate different statuses within the user interfaces, we often use color. Red for errors, green for success statuses, and so on. And while there's nothing necessarily wrong with that, we need to remember that different people perceive color differently. So to avoid this color trap, we need to make sure there's also another way to convey the same information. And usually displaying an icon, like a check mark and warning icon, is enough to already make it a lot more universal. Now getting back to the form, we usually have two main types of validation that we can provide. Submit validation after submit button is clicked, or instant validation. Let's talk about submit validation first. If the user input is incorrect or there is some data is missing, one pattern that I often see implemented within the forms is that the submit button is made disabled, like this. I would strongly recommend avoid doing that, because disabled buttons are not navigable via keyboard and they create a dead end for the users. They prevent them from understanding what is wrong or missing within the form. So it's usually better to keep the button enabled, but validate input when it is clicked and display error messages. Now let's see how we can implement these error messages. Let's start with input level ones first. Right now we made this input we made a red border and we are displaying an icon to communicate to the user that something is wrong. But we also need to provide a semantic cue for somebody who cannot see all of these changes. To do that, we can use area invalid area attribute. And if set, screen reader will actually communicate that this input contains invalid data. One handy tip in here, we can actually use all of these area attributes for styling as well. First of all, it is just easier because you don't need to provide additional CSS class, but it is also more reliable because it makes sure that your visual cues, like red border, and your semantic cues, area invalid attribute, are always in sync. Now, as we marked visually and semantically this input as invalid, we also need to display and communicate an error message. And we can connect it to the input the same way as we did with the hint. Area described by attribute can actually accept several element IDs and will concatenate them together when announcing to the user. So now When the error is displayed and we navigate to the input, it will sound something like this.
Username required invalidate edit text. This username is taken.
In addition to displaying inline error messages near individual fields, it is also a good idea to display an error summary for the whole form, especially in a longer form like ours. But if we consider experience for somebody who cannot see the UI, so if I am as a sighted user, I click submit button and all these red things start flashing in my face, it is very clear that something is wrong. But for somebody who cannot see all of those changes, we need a different way of notifying them about them. And to do that, we can use area live regions, which is really important and powerful feature of ARIA that allows us to define certain areas within the page as live. And then, no matter where on the page screen reader is positioned at the moment, if something within that region changes, it will get notified, and therefore can announce the change to the user without losing its current position. So we can set it with area live attribute, which supports several settings. It can be polite, meaning that screen reader will wait for whatever it was saying before announcing the change. Or it can be assertive, meaning that we will interrupt the speech for the announcement. It is a very powerful feature to communicate alerts, errors, and different statuses, which is exactly what we need. So to use that, we can set area live attribute assertive for our error message, and then when we submit the form, it will be read out to the user like this.
Sign up failed. Username and email fields are invalid.
Instead of setting area live attribute directly, we can also set a role alert, which will implicitly under the hood set area live to assertive, and will basically achieve the same purpose. We can use the same approach for success messages as well.
Sign up button.
Like this.
Account created. Check your email for confirmation.
And that is submit validation. So now as we learned how to implement submit validation and validate input when the user submits a form, let's talk about instant validation as well. Because in some cases it might be better for the user experience to provide instantaneous feedback as they input the data into the field. For example, a really good use case is username validation. So as I type and I change something within my input, I can receive instant feedback. Let's see how we can implement it accessibly. To use this, we can basically utilize the same approach, but we can set the role alert to the input level error message as well, and therefore as I type, it will be announced to me via screen reader. We can use the same approach for less important or maybe less critical information like different statuses or character limits within the form, like here, and then we would use area live polite attribute to make sure that it is not as disruptive to the user. And instead of setting area live polite, we can also set role status, which will set area live to polite under the hood implicitly as well. Live regions are very powerful, but at the same time, they also need to be used with caution. So only in cases where we really need them. Because if you always have a lot of notifications to the user, it can also create a very disruptive experience and change the natural order of navigating the page. So now we implemented a lot of different accessibility features within the form. Let's look at all of them together and see what the experience of filling this form is like.
Username required edit text. Username is too short. This username is taken. 2. Username is available. Email address required menu pop-up edit text email. Display name required menu pop-up edit text. Kateryna Porshnieva window. Website edit text URL. About you edit text. Sign up button. Sign up failed. Email field is invalid. About you website Kateryna email address k.porshnieva@gmail.com window. About you sign up button. Account created. Check your email for confirmation.
Yay! So as you can see with the whole experience, all the labels were announced. We also used autocomplete to make sure that it is easier to just choose elements in the pop-up and the instant and submit validation in action as well. Now, before wrapping up, I want to also talk about how to test whether the features you implement are indeed accessible. First of all, there are some automated tools. For example, there's XDev tools that can check some basic accessibility warnings for you. There's also a very useful plugin for ESLint called JSConf that you can use that can check some statically analyzable accessibility warnings. For example, if you're using incorrect roles or using area attributes that conflict between each other, or to make sure all the images have alt text and so on. But there's only so little that can actually be caught by automated tools. So another way that I really like, and if you're already writing a lot of automated tests, for example, with testing library or with Playwright, which has very similar functions, instead of using, for example, get by test ID or finding elements by classes or their tags, we can use semantic locators instead. For example, this is the test that covers the same flow that we just saw in the video. So we can use get by label text to find elements with correct labels. And by also serving the purpose of finding the element, we'll also check to make sure that it actually has correct accessible label connected to the control. We can also assert specific semantic attributes like required as well, or invalid like here. Then, for example, with the alerts or area live attributes, we can find them by role and make sure that they have correct context. Additionally, we can also submit the form here, make sure that the error message is displayed correctly, then also check that some of the needed inputs within the form are invalid and have correct errors connected to them, and then submit again, and also make sure that the success message is displayed. But of course, nothing compares to actual lived experience of using the screen reader. So if you have never used the screen reader before, I really recommend installing and trying. And macOS comes built in with VoiceOver, a screen reader, as well as iOS as well. There's also NVDAs and JAWS for Windows, and TalkBack on Android. There's also this really cool series of YouTube videos from Rob Dodson, and there's also guides on how to use different screen readers within it. But of course, the way that you as a developer would use a screen reader is very different to how the person with an actual disability would. So if you have a way to connect with existing users with disabilities, I think it can be such an eye-opening experience, but in some cases also might not be possible. So for that purpose, there's also this service called Fable that can connect you with people with disabilities, and then they can help you test your product for various accessibility features and provide feedback. Now, as the last thing, I want to note that accessibility is not black and white. And by learning more and continuously improving and making small steps, we can move towards a more accessible and inclusive web for everybody. I hope you like this talk. You can scan this QR code to find my slides and also a lot of links of the things that I mentioned throughout the talk for additional information, videos, articles, specifications, and so on. And thank you for listening, and let's make forms more accessible. Bye.